All right, let's talk about statistics. And hey, if that word just made you groan and think about some boring math class, stick with me. We're about to change that. Seriously, forget all the crazy formulas for a second. At its core, statistics is just this incredibly powerful toolkit for making sense of the world, for turning a whole lot of confusion into real clarity. And today, we're going to build that toolkit together, right from the ground up.
So, let's jump right in with a challenge. Imagine you work for a huge game company. Your job? To create the next blockbuster hit. You've got the budget, you've got the team, but what kind of game do you actually make? A massive fantasy world? A sci-fi shooter? A clever little puzzle game? I mean, how on earth do you figure out what millions of different people are actually going to want to play? That's the exact question we're going to tackle.
You see, to build that hit game, you can't just jump in and start designing characters. The very first step, and honestly, the most important one in any data journey, is about asking the right questions. We have to figure out what we need to know before we can even dream of finding an answer.
And here's the first big hurdle. Your potential audience is, well, it's global. We're talking tens, maybe even hundreds of millions of people. There is just no way you can survey every single one of them. It would take forever, cost a fortune, and by the time you got your answer, the trends would have totally changed anyway. It's just not going to happen.
This is where statistics becomes our hero. If asking everyone is completely off the table, what do? What's the next best thing? How can we get a solid, reliable answer without having to talk to millions of people? Well, the solution is actually pretty cool.
That solution really boils down to a choice that statisticians make all the time. Do we try to study everyone, or do we focus on just a select few? This simple choice introduces us to two of the most fundamental ideas in all of statistics.
Okay, first up, we have the population. Now, in statistics, this doesn't just mean the number of people in a country. It means the entire group you want to know something about. So for our game company, the population isn't just gamers. It's every single person on Earth who might possibly buy their new game. It's the whole shebang, the entire universe of people we're interested in.
And like we just said, trying to study that entire population is a logistical nightmare. It's like trying to count every single grain of sand on a beach. So yeah, we need a much smarter way to go about this.
And here is that smarter way. It's called the sample. A sample is just a small, manageable piece of the population that's been carefully chosen to represent the whole thing. So instead of trying to reach millions of gamers, our company might survey, say, 1,000 of them. The whole idea, and this is so important, is that by studying this small group, we can learn a whole lot about the giant group.
So it's all about a trade-off, right? A census, that's when you study the entire population, is incredibly detailed, but it's also incredibly expensive and slow. A sample survey, on the other hand, is way faster and way cheaper. And get this, if you choose your sample the right way, your results can be just as accurate. It's all about working smarter, not harder. Okay, so our game company surveyed their sample of 1,000 players. They've got the data. Now what? Well, there are basically two main things they can do with it, and these represent the two major branches of statistics.
Once you've got your hands on that data, you can take it down two main roads, descriptive and inferential. Now, they might sound a bit technical, but I promise the ideas behind them are super intuitive. Let's break them down.
First, you've got descriptive statistics, and it's exactly what it sounds like. It describes the data you have. This is the just the facts part. Our game company would take all those survey results and organize them into charts and calculate averages. They might find out that, say, 70% of the players in their sample love fantasy games, or that the average player is 28 years old. It's all about creating a crystal clear snapshot of the small group they actually talk to.
But just describing your little sample is only half the battle. This next part is where the real magic happens, inferential statistics. This is where you take that descriptive data and you make a huge leap. The game company takes the fact that 70% of their sample liked fantasy games to infer, which is just a fancy word for making an educated guess, that probably around 70% of all potential players in the world will also like fantasy games. You're using the little group to predict what the giant group will do. Pretty powerful, right?
So, we know we're going to grab data from a sample and then use it to make these big, educated guesses. But what does that data actually look like? Well, it turns out that not all data is created equal. The type of information you collect actually determines the kinds of questions you can answer.
At the very top level, we can split all data into two big families. You've got categorical data, which is all about labels and categories, think words, and then you have measurement data, which, you guessed it, is all about numbers. And we can zoom in even one step further. Each of those two big families can be broken down again. Categorical data splits into what we call nominal and ordinal, and measurement data splits into discrete and continuous. Let's really quickly see what each of these means, and we'll stick with our video game example.
Let's start with nominal data. Think of these as just labels, where the order doesn't matter one bit. An RPG isn't better or worse than a shooter, they're just different. It's like asking someone their favorite color. The categories are just names, which is where the word nominal comes from.
Next up is ordinal data. These are also labels, but this time the order is everything. We all know that a gold rank is higher than silver, and silver is higher than bronze. The categories have a meaningful order, or a rank. Another great example is a survey that asks if you disagree, are neutral, or agree. The order there definitely matters.
Now let's hop over to the number-based data. Discrete data is anything you can count in whole numbers. So think about the number of quests a player has finished. It could be 5, or 6, or maybe 20, but it can never be 5.5 quests, right? There are these clear, separate, countable gaps between the values.
And finally, we've got continuous data. This is stuff you measure, and it can take on any value in a range, including all the fractions and decimals in between. A person to play for 12 hours, or 12.5 hours, or even 12.513 hours. If you had a precise enough stopwatch, there are basically infinite possibilities. Think about things like height, weight, or temperature.
Phew, okay, we've covered a lot of ground here. From these huge ideas like populations and samples, all the way down to the nitty-gritty of data types. So let's just take a breath, step back, and see how our new toolkit all fits together.
So here's the bottom line. You start with a giant population you want to understand. Since that's usually impossible, you pick a small representative sample. Then, you use descriptive statistics to simply summarize what you found in that sample. And after that, you use inferential statistics to make a smart guess about the entire population. And the kinds of questions you can even ask depend on the type of data you collect. That's it. That's the fundamental recipe for making smarter, data-driven decisions.
Whether it's building the next hit video game, figuring out if a new medicine works, or understanding what a political poll really means, this basic toolkit is the foundation for all of it. It's a method for cutting through all the noise out there and finding real answers. So the real question is for you, what are you curious about? What problem in your world could you start to figure out using these ideas?